Right now, as you hear this, two people are walking past each other on a sidewalk somewhere on Earth. One of them is heading east. The other is heading west. They are moving at maybe 3 miles per hour relative to each other. And according to the physics that has been settled and confirmed for over a century, those two people disagree about what is happening right now on the Andromeda galaxy. Not by a little, not by some imperceptible fraction of a nanosecond that you could wave away as a technicality. They disagree by an entire day. One of them inhabits a present moment in which, 2.5 million light-years away, an event has already happened. The other inhabits a present moment in which that same event has not happened yet. And here is the part that should unsettle you. Neither of them is wrong. There is no fact of the matter about which of them is experiencing the real now. The universe does not have one. It never did. This is not speculation. This is not a fringe interpretation. This is what the Lorentz transformation, the foundational equation of special relativity, has been telling us since 1905. And it gets worse, because in 1966 and 1967, two independent thinkers, a Dutch physicist named C.W. Rietdijk and the American philosopher Wheeler-Putnam, took this result and followed it to its logical conclusion. They published separate proofs, one in Philosophy of Science and one in the Journal of Philosophy, showing that if special relativity is correct, then every event that you consider to be in your future is already real, already determined, already existing in someone else's past. The present moment, the thing you feel more certainly than anything else in your life, the thing that seems so obviously real that questioning it feels like questioning whether you exist, was formally proven to be meaningless over half a century ago. Those proofs have never been overturned. And the neuroscience that came later would make the situation incomparably darker, because it would show that whatever you are experiencing when you feel now is not just absent from the equations. It is being actively manufactured by your brain roughly half a second after the events it claims to be showing you in real time. You are watching a forgery. You have always been watching a forgery, and the people who understand this best cannot tell you what is doing the forging or why. But before we get there, before the neuroscience makes this personal, you need to understand how the physics community arrived at this conclusion. And that story begins with two men walking home from work in Bern, Switzerland, sometime around 1904. Michele Angelo Besso was 6 years older than Albert Einstein. They met in Zurich around 1896, when Einstein was a student at the Swiss Polytechnic, and Besso was a young mechanical engineer with wide-ranging intellectual interests and absolutely no career ambition. Besso introduced Einstein to the philosophical writings of Ernst Mach, the Austrian physicist who argued that concepts like absolute space and absolute time were meaningless because they could never be observed. That introduction changed the direction of physics. Mach's skepticism about unobservable absolutes planted the seed that would become special relativity. Einstein would later say that without those conversations with Besso, he might never have arrived at the theory. Einstein helped Besso get a job at the Swiss Patent Office in Bern in 1904. They walked home together almost every day, talking about physics, philosophy, the nature of space and time. Einstein used Besso as his sounding board, testing ideas out loud, pushing against Besso's gentle resistance. He called Besso the best sounding board in all of Europe. When Einstein published his 1905 paper on the electrodynamics of moving bodies, the paper that introduced special relativity to the world, it contained 0 references to other physicists, 0 citations, just a single acknowledgement at the end thanking his friend and colleague M. Besso for many a valuable suggestion. No other name appears. Their friendship lasted 60 years. Over 200 letters survive. They discussed physics, aging, regret, mortality. And then, on March 15, 1955, Michel Besso died in Geneva. He was 80, 1 year old. 6 days later, Einstein wrote a letter to the Besso family. He was 76. He had weeks to live, though he did not know that yet. In the letter, he wrote something that has been quoted so often it has been drained of its meaning, turned into a greeting card sentiment about mortality. But it was not a greeting card. It was a statement about physics from a man who understood his own theory better than anyone alive. Einstein wrote, in German, that Besso had departed from this strange world a little ahead of him, that this meant nothing, and then the line that matters. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. 26 days later, on April 18th, 1955, Einstein was dead. You have almost certainly encountered that quote before, and you have almost certainly been told it is a poetic consolation. A beautiful way of saying that death is not real because time is not what it seems. That is not what it is. It is a literal statement about the equations Einstein spent his life developing. The physics of special and general relativity contains no universal present moment. There is no now in the equations. There never was. Einstein was not being poetic. He was being precise, and the fact that this quote has been domesticated into a spiritual platitude about the afterlife, stripped of its actual physics content, is itself a kind of quiet scandal. The most disturbing implication of the most thoroughly confirmed theory in the history of science turned into a refrigerator magnet. But you need to understand why the equations say this, and you need to understand it specifically enough that you cannot dismiss it as interpretation. So here is what special relativity actually proved about now. Einstein's theory rests on two postulates. The laws of physics are the same in all inertial reference frames, and the speed of light in a vacuum is the same for all observers, regardless of their motion or the motion of the source. From these two postulates, everything follows, including the death of the present moment. The specific result is called the relativity of simultaneity, and it is described by the Lorentz transformation if two events happen at different locations but at the same time according to one observer. A second observer moving at velocity v relative to the first will measure a time difference between those events equal to gamma times v times the spatial separation divided by the speed of light squared. The gamma factor is the Lorentz factor, which is close to 1 at everyday speeds but grows toward infinity as you approach the speed of light. The point is this. If you set the time difference to 0, meaning the events are simultaneous for one observer, the equation gives a non-zero time difference for any other observer in relative motion. Simultaneity is not a fact about the universe. It is a fact about your velocity. Einstein illustrated this with a thought experiment. Lightning strikes both ends of a moving train at the same instant, as judged by an observer standing on the embankment midway between the strikes. Light from both strikes reaches this observer at the same time, but a passenger standing at the midpoint of the train is moving toward one strike and away from the other. The light from the front strike reaches the passenger first. The passenger concludes, correctly in their frame, that the front strike happened before the rear strike. Both observers are right. There is no experiment either of them can perform to prove the other wrong, because the universe does not have a preferred frame. It does not have a shared now. Each observer has what physicists call a hyperplane of simultaneity, a three-dimensional slice through four-dimensional space-time that represents everything happening at the same time, according to that observer. Different observers have different hyperplanes tilted relative to each other, depending on their relative velocity. There is no physically preferred way to slice space-time into moments of now. The slicing depends on who is doing the slicing. This brings us back to the Andromeda paradox. The physicist Roger Penrose described it in his 1989 book, The Emperor's New Mind. Two people pass each other on a street. One is walking toward the Andromeda galaxy, one is walking away. The Andromeda Galaxy is approximately 2.5 million light-years from Earth. That is an enormous distance, roughly 2.4 times 10 to the 22nd power meters. But the Lorentz transformation does not care about speed alone. It cares about speed multiplied by distance. And when the distance is 2.5 million light-years, even a walking speed of a few feet per second produces a significant tilt in the hyperplane of simultaneity. The math is straightforward. For a relative velocity of about 1 foot per second and a distance of 2.5 million light-years, the time offset is approximately 83,000 seconds. That is roughly 1 Earth day. Two people walking past each other on a sidewalk have present moments on Andromeda that differ by a day. If their relative velocity is a few miles per hour, the disagreement grows to several days. Penrose pointed out the implications in his characteristically understated way. According to one person, an Andromedan space fleet has already set off on its journey. According to the other, the decision about whether to launch has not yet been made. How can there be uncertainty about the outcome if, for one of them, it has already happened? The launching of the space fleet, Penrose wrote, is an inevitability. You might want to object here. You might want to say that this is just a coordinate effect, that nobody can actually observe what is happening on Andromeda right now, because the light takes 2.5 million years to arrive, that in practice, the disagreement is undetectable, and therefore meaningless. And this is exactly the objection that Rietdijk and Putnam addressed. Their argument does not depend on anyone observing Andromeda. It depends on a simple chain of logic about what is real. Here is how the argument works. Consider two observers, A and B, in relative motion. At the moment they pass each other, they share the same space-time location. An event E lies in A's future. But by the Lorentz transformation, that same event E can lie in B's past, if B is moving at the right velocity. Now, if everything in B's past is real, already determined, already settled, then event E is real for B. But B is in A's present. B exists right now for A, and if something is real for an entity that exists right now, then it is real. Period. Therefore, event E, which is in A's future, is real. And this applies to any future event for any observer. Your entire future already exists. Putnam put it with a bluntness that philosophy rarely permits. We now discover something really remarkable, he wrote in 1967. On every natural choice of the relation, it turns out that future things are already real. Think about what this means for the present moment. If your future is already real, then now is not a boundary between what exists and what does not yet exist. Everything exists. Past, present, future. All of it. Simultaneously. Eternally. The block universe. A four-dimensional solid in which your entire life, from birth to death, is a frozen thread called a world line. And the feeling of moving through time is something that thread experiences from the inside, but that has no objective counterpart in the structure of reality. The philosopher Howard Stein objected in 1968, arguing that the concept of real for cannot be transitively extended across different reference frames in the way Rietdijk and Putnam assumed. His critique is technically sophisticated and widely cited, but it does not rescue the present moment. Even under Stein's more cautious framework, the present can only be defined at a single space-time point. It cannot be extended to any distant event. The question, what is happening right now on Andromeda, is simply not well defined, not ambiguous, not uncertain, meaningless. The present, if it exists at all, exists only here, only for you, only at this exact point in space-time. It cannot be shared, it cannot be extended, and it cannot be reconciled with any other observers present. And this is just special relativity. Flat space-time, no gravity. The basic case. because general relativity makes this incomparably worse. When Einstein completed general relativity in 1915, he showed that gravity is not a force, but a curvature of space-time, caused by mass and energy. One of the consequences is gravitational time dilation. Clocks closer to a massive object tick more slowly than clocks farther away. This is not a metaphor. This is not an artifact of measurement. Clocks in different gravitational fields genuinely accumulate different amounts of elapsed time. You carry proof of this in your pocket. The Global Positioning System uses 24 satellites orbiting at approximately 200 kilometers above the Earth. Those satellites move at about 3,874 meters per second, which produces a special relativistic time dilation that makes their clocks fall behind ground clocks by roughly 7 microseconds per day. But they also sit higher in Earth's gravitational field, where gravity is weaker, which produces a general relativistic effect that makes their clocks run faster by approximately 45 microseconds per day. The net result is that GPS satellite clocks gain about 38 microseconds per day relative to clocks on the ground. If this were not corrected, your GPS position would drift by roughly 10 kilometers per day. It is corrected. Every GPS calculation you have ever relied on, every turn-by-turn direction, every food delivery estimate works because engineers account for the fact that now on the satellite and now on the ground are not the same thing. You use the non-existence of the universal present every time you open a map on your phone. You just never realized it. General relativity takes the problem further because it eliminates any natural way to define a universal now, even in principle. In special relativity, at least you could argue for a preferred frame tied to the cosmic microwave background, or the average motion of matter. In general relativity, space-time is curved, dynamic, and there is no preferred foliation into spatial slices. Cosmologists use a convention called cosmic time, defined for observers moving with the expansion of the universe, but this is a human convenience, not a physical fact. It applies only to a specific idealized model. In the real universe, with its lumpy distribution of matter and its varying gravitational fields, there is no physically meaningful way to say, this is the present everywhere. And then there is Gödel. This is where the story takes a turn that even Einstein found difficult to absorb. Kurt Gödel arrived at the Institute for Advanced Study in Princeton in 1940. He was already the most important logician since Aristotle, having published his incompleteness theorems in 1931, proving that any consistent mathematical system powerful enough to describe arithmetic must contain true statements it cannot prove. He was thin, meticulous, brilliant, and profoundly strange. He would later starve himself to death out of paranoia that his food was being poisoned, dying in 1978 at 65 pounds. At Princeton, Gödel and Einstein became inseparable. They walked to and from the institute together every day, conversing in German. Einstein rumpled and baggy-pantsed, alongside Gödel in his white linen suit and fedora. The economist Oscar Morgenstern reported that near the end of his life, Einstein confided that his own work no longer meant much to him, and that he came to the institute merely to have the privilege of walking home with Kurt Gödel. Freeman Dyson said Gödel was the only colleague who walked and talked on equal terms with Einstein. In 1949, for Einstein's 70th birthday, Gödel gave his friend a gift that was either the most generous or the most devastating birthday present in the history of science. He gave Einstein a new solution to Einstein's own field equations. Gödel had found a model of the universe consistent with general relativity, in which the entire contents of the cosmos rotate relative to the compass of inertia. He published it as an example of a new type of cosmological solutions of Einstein's field equations of gravitation in Reviews of Modern Physics. The paper is 4 pages long. It is a bomb. In Gödel's rotating universe, there are closed time-like curves, paths through space-time that loop back on themselves. A traveler following such a path would return to their own past. Time travel is physically possible in this universe, not as science fiction, as a mathematical consequence of Einstein's own theory. And Gödel's philosophical argument, published separately in the same year in the Festschrift volume Albert Einstein Philosopher-Scientist, was devastating. If a universe without a meaningful now is possible under the laws of general relativity, if the equations permit a universe where you can travel to your own past, then the flow of time cannot be a fundamental feature of reality. Because fundamental features of reality do not come and go depending on whether the matter in the universe happens to be rotating. Time, Gödel argued, is either real in all solutions of Einstein's equations, or real in none of them. Since it is clearly not real in his solution, it is not real in ours either. The philosopher Palaiograu called this gift a bomb lobbed into the foundations of physics. Einstein acknowledged the result in his reply in the same volume. He did not dispute the mathematics. He suggested that Gödel's solution might be excluded on physical grounds, meaning it might not describe our actual universe. And it does not. Our universe does not appear to rotate globally. But that is not the point. The point is that Einstein's own equations, the most thoroughly tested equations in all of physics, permit a universe in which time does not exist in any meaningful sense. And if the equations do not require time, then time is not built into the fabric of reality. It is an accident, a contingent feature of the particular solution we happen to inhabit, if we happen to inhabit one at all. You might be hoping at this point that the block universe is just one interpretation, that there is another way to read the equations, that maybe the math describes reality without being reality, that somewhere, in some framework, the present moment survives. This is where McTaggart becomes relevant, not as philosophy, but as evidence. In 1908, the same year Minkowski delivered his famous address in Cologne, declaring that space by itself and time by itself are doomed to fade away into mere shadows. The British philosopher John McTaggart, Ellis McTaggart, published a paper in the journal Mind, titled The Unreality of Time. His argument is deceptively simple and has resisted all attempts at refutation for over a century. McTaggart distinguished between two ways of ordering events in time. The A-series orders events as past, present, and future. These are dynamic properties. An event that is now in the future will eventually become present, then past. The B-series orders events as earlier than and later than. These are static relations. If the Battle of Hastings is earlier than the moon landing, that relation never changes. McTaggart's argument has two parts. First, he argues that time requires change, and the B-series alone cannot provide it. The B-series relations are permanent. The Battle of Hastings is always earlier than the moon landing. Nothing changes in the B-series. Therefore, genuine change requires the A-series, the movement of events from future to present to past. Without the A-series, there is no real time. Second, and this is the lethal step, McTaggart argues that the A-series is contradictory. Every event must possess all three A-series properties. Any event that is now present was once future and will be past, but past, present, and future are mutually incompatible. An event cannot be all three simultaneously. The standard objection is that the properties are had successively, not simultaneously. The event is future, then present, then past. But McTaggart pointed out that then reintroduces A-series concepts. You are using temporal change to explain temporal change, and the same contradiction reappears at this higher level. You can try to resolve it again, but you generate the same problem at a still higher level, and so on forever. An infinite vicious regress that never bottoms out. The standard response in analytic philosophy is that McTaggart's argument is wrong somewhere, but nobody fully agrees on where. That has been the situation since 1908. Over 115 years, the argument sits there like a splinter, not quite fatal, not quite removable. And in the context of this script, what matters is not whether McTaggart was ultimately right. What matters is that the best philosophical minds of the last century have not been able to definitively rescue the present moment from his attack. And physics, independently and using completely different methods, arrived at the same conclusion. But here is the thing. Everything up to this point, all of the relativity, the block universe, Gödel's rotating cosmos, McTaggart's paradox, all of it can be filed under physics and philosophy. It can be kept at arm's length. You can nod along and say, yes, the equations do not contain a now. That is very interesting. And then go about your day feeling exactly as present as you always have. Because the experience of now feels so real, so immediate, so undeniable that no equation can touch it. Which is exactly why the next part of this story is so much worse. Because physicists are not the only ones who have been investigating the present moment. Neuroscientists have too. And what they found is that the experience of now, the thing that feels so self-evidently real that you would bet your life on it, is a fabrication, built after the fact, backdated to hide the construction. And you have been living inside that fabrication for every second of your entire life, without once catching it in the act. But before we get to the neuroscience, there is something deeper that needs to be confronted, because the block universe, disturbing as it is, still treats time as one of the four dimensions of space-time. Time is there in the equations, even if now is not. Time is woven into the fabric. It has a direction. Things happen earlier and later. The past is the past and the future is the future, even if they both exist. In the block universe, time is real. It just does not flow. What if time is not even that? What if the most fundamental equation we have for the universe, the equation that would describe all of reality if we could solve it, does not contain time at all? Not as a flow, not as a dimension, not as anything. This equation exists. It was conceived in 1965 at the Raleigh-Durham Airport in North Carolina, during a 2-hour layover between flights. John Archibald Wheeler was the one with the layover. Wheeler was one of the most important physicists of the 20th century, though you have probably never heard of him. He earned his doctorate at Johns Hopkins University at the age of 21. He worked with Niels Bohr on the theory of nuclear fission. He helped develop the hydrogen bomb. He taught Richard Feynman, Kip Thorne, and Hugh Everett. He coined the terms black hole, wormhole, and quantum foam. He was the kind of physicist who, when journalist John Horgan visited him at Princeton in 1991, refused to take the elevator, saying elevators are hazardous to your health, then charged down the stairs, hooking his arm inside the banister and letting centrifugal force whirl him around each landing. He was 80 at the time. During his layover at Raleigh-Durham, Wheeler called Bryce DeWitt at the University of North Carolina in Chapel Hill and proposed they meet at the airport. DeWitt came. He brought along the Hamilton-Jacobi equation of general relativity, which had been recently published by Asher Perez. DeWitt mumbled an idea. What if you did what Schrödinger did for the hydrogen atom? Take the classical equation for gravity and replace the classical momentum squared terms with quantum mechanical second derivatives. Turn it into a wave equation, a quantum version of general relativity. Wheeler, according to DeWitt's account, got tremendously excited and declared on the spot that the equation for quantum gravity had been found. DeWitt published the result in 1967 in Physical Review. It is now called the Wheeler-DeWitt equation, and it has a property that has haunted theoretical physics for nearly 60 years. The standard Schrödinger equation, the one that governs all of quantum mechanics, has a time derivative on the right-hand side. The wave function evolves, it changes, things happen, The Wheeler-DeWitt equation does not have a time derivative. The right-hand side is zero. The wave function of the universe, if this equation is correct, does not evolve. It does not change. Nothing happens. The universe, at the most fundamental level we can describe it, is frozen. This is not a bug in the equation. This is not something physicists think they will fix when they get a better version. This is a direct consequence of applying quantum mechanics to a system where time is not external, but is part of what is being quantized. In ordinary quantum mechanics, time is a background parameter. It sits outside the system. The electron evolves in time. Time is the stage, not the actor. But in quantum gravity, you are quantizing space-time itself. There is no external time for the universe to evolve in. The universe is everything. There is nothing outside it to provide a clock. And so the equation that describes the quantum state of the universe is timeless, static, eternal. The technical name for this is the frozen formalism problem, or the problem of time in quantum gravity. It has been the central unsolved problem in the field for decades. Rovelli described the equation with an honesty that is rare in physics. Disavowed by one of its fathers, ill-defined, never empirically tested, the Wheeler-DeWitt equation has nevertheless had a profound influence on fundamental physics. A well-deserved one. He was right about the influence, and he was right about the disavowal. Bryce DeWitt himself spent years expressing doubts about what the equation meant. Wheeler embraced it enthusiastically but never resolved the time problem. The equation sits at the center of quantum gravity like a locked door that everyone can see but nobody has the key to open. And what is behind that door, if the equation is telling the truth, is a universe that does not experience time. That does not contain a now. That simply is. And here is where it gets worse. Because two physicists looked at this frozen equation and asked a question that should disturb you. If the universe does not evolve, then where does time come from? Why do we experience it? And their answer was that time is not a feature of reality. It is a feature of our ignorance. In 1994, Alain Connes and Carlo Rovelli published a paper titled Von Neumann Algebra Automorphisms and Time Thermodynamics Relation in Generally Covariant Quantum Theories in Classical and Quantum Gravity. It is one of the most quietly radical papers in modern physics. Their proposal is called the thermal time hypothesis, and it says this: in a universe where there is no fundamental time, the experience of time flow emerges from thermodynamics. Specifically, from the fact that we, as observers, do not have access to the complete microscopic state of the universe. We see a coarse-grained thermodynamic description, and the mathematical structure of that incomplete description, via a result called the Tomita-Takaki theorem, automatically generates a one-parameter group of transformations that looks exactly like the flow of time. Time, in this framework, is what statistical ignorance feels like from the inside. Think about what this means. The universe, fundamentally, is timeless. Nothing happens, nothing evolves. The wave function sits there, but because you do not know the full microstate, because you are a small subsystem with limited access to the whole, you experience something, a flow, a direction, a now, and that experience is not a window onto something real. It is an artifact of your limitations. If you knew everything, if you could see the universe as it fundamentally is, time would disappear. The flow would stop. Now would dissolve. You would see what Einstein saw in the equations but could never convey in a letter, that the distinction between past, present, and future is a stubbornly persistent illusion generated not by the universe but by the boundaries of your own knowledge. Carlo Rovelli is the person who has done the most to carry this idea to the public, and his biography is itself a story about time and what happens when you take it away. He was born in Verona, Italy, in 1956. In the 1970s, as a university student, he was deeply involved in the Italian student movements. He co-founded a free radio station called Radio Anguana. He was associated with the Metropolitani Indiani, a countercultural group known for dressing as Native Americans at protests. He co-authored a pamphlet about the university uprising, for which he was charged with crimes of opinion. He refused compulsory military service and was briefly detained by the Italian authorities. As the radical dreams of the 70s faded, Rovelli turned to physics. He studied at the University of Bologna, largely self-taught, buying 3 books on every topic where his professors recommended one. After his doctorate from Padova in 1986, the university gave him a small office in a basement and forgot about him. From that basement, Rovelli began writing letters to leading quantum gravity researchers around the world. One of them was Lee Smolin. They became friends, spending late nights together solving equations and arguing about the foundations of physics. Together with Abai Hashteka, they introduced loop quantum gravity in 1988, a framework for quantizing spacetime that remains one of the leading candidates for a theory of quantum gravity. It was from this work that the thermal time hypothesis emerged. Rovelli was not just solving equations, he was trying to understand what it means to live in a universe where the fundamental theory has no time. And the answer he arrived at is the one that should keep you awake. Time is not a feature of the world. It is a feature of the particular way you happen to be entangled with the world. If you were entangled differently, or not at all, there would be no time. No now. No before and after. Just a static, eternal wave function of a universe that does not need any of those things to exist. Rovelli wrote about this with unusual emotional directness in his 2018 book, The Order of Time. We conventionally think of time as something simple and fundamental, he wrote, that flows uniformly, independently from everything else, from the past to the future. And yet all of this has turned out to be false. One after another, the characteristic features of time have proved to be approximations, mistakes determined by our perspective, just like the flatness of the Earth. He was even more specific about the present. If I ask whether 2 events, one on Earth and the other on Proxima b, are happening at the same moment, the correct answer would be that the question does not make sense, because there is no such thing as the same moment definable in the universe. The present of the universe, he wrote, is meaningless. There is a version of this story that ends here. The physics says, now does not exist. The thermal time hypothesis says the experience of time is generated by ignorance. You could stop here, feel appropriately unsettled, and go about your life. But that would be like hearing the first movement of a symphony and thinking you had heard the whole piece. Because so far, everything has been about what the universe does or does not contain. The present is not in the equations. Time may not be fundamental. These are statements about physics. But there is another question, a closer and more personal question, that the physics alone cannot answer. If now does not exist out there, in the fabric of reality, then what is happening in here, in your skull? Right now, as you hear this sentence, you are having an experience of the present moment. That experience is vivid. It is immediate. It is the most certain thing in your conscious life. And if the universe does not provide it, then something else is manufacturing it. Your brain is generating the illusion of now. And when neuroscientists investigated how it does this, what they found was not just that the illusion exists. They found how it is constructed, and the construction process is far stranger, far more unsettling, and far more complete than the physics alone could have predicted. Because your brain does not just fail to detect the real present, it builds a fake one, and it has been doing it so seamlessly for so long that you have never once suspected you are living inside a temporal forgery. That discovery begins with a man named Benjamin Libet and an experiment that would take nearly 40 years to be properly understood. Benjamin Libet was born on April 12, 1916, in Chicago, to Ukrainian Jewish immigrants. He spent his career at the University of California, San Francisco, in a department of physiology that gave him access to something almost no other researcher had: patients with electrodes already implanted in their brains for medical purposes. Beginning in the late 1950s, Libet used this access to measure something that nobody had thought to measure before: the timing of conscious experience. How long does it take for a stimulus to become a conscious sensation? And his answer, published over a series of papers from 1964 through 1983, was approximately 500 milliseconds. Half a second. That number alone should concern you. It means that your conscious experience of the present moment is lagging behind what is actually happening by roughly half a second. When you touch a hot stove, the neural signal reaches your primary somatosensory cortex in about 25 milliseconds, but you do not become conscious of the pain for approximately 500 milliseconds. Your hand has already jerked away by then, pulled back by a spinal reflex that does not need consciousness. The withdrawal happens in the real present. Your experience of the pain happens in the reconstructed past. But here is the part that made Libet's work genuinely disturbing. He found that despite this half-second delay, subjects report feeling the sensation at the time of the stimulus, not half a second later. The brain does not just lag behind reality, it backdates the experience. It stamps the conscious sensation with a timestamp that says, this happened at the moment of contact, even though the sensation was actually constructed nearly 500 milliseconds later. Libet called this backward referral, and he published a key paper on it in 1979 in Brain, co-authored with Wright, Feinstein, and Pearl. The brain, he showed, uses the initial cortical response, the fast signal that arrives in 2005 milliseconds, as a time marker. Then, when consciousness finally catches up half a second later, it refers the experience backward to the time of that marker. You never notice the delay because the forgery is seamless. Your subjective experience of now is always approximately half a second in the past, but you would never know it because the brain has altered the timestamp. If this were the only finding, it would be enough to fundamentally alter your understanding of the present moment. You have never experienced the present. Every sensation you have ever had was constructed after the fact and stamped with a false timestamp. But Libet's most famous experiment, published in 1983 in Brain, went even further. It attacked the present not just as a sensory experience, but as the seat of conscious decision-making, the moment where you choose to act, the moment that feels most like the real undeniable now. The experimental setup was simple. Subjects sat in front of a cathode ray oscilloscope displaying a clock face with a dot revolving around it. The dot completed a full revolution every 2.56 seconds. Around the clock face were 24 short radial lines, spaced at intervals of about 107 milliseconds. Subjects were told to perform a quick, abrupt flexion of the fingers or wrist of their right hand whenever they felt like it. There was no schedule, no signal, no external prompt. Just decide to move whenever you want. Then, after moving, report the position of the revolving dot at the moment you first felt the urge to move. That reported time was called W for willing. Meanwhile, an electromyograph detected the onset of muscle movement, and EEE electrodes monitored brain activity throughout. The results destroyed the common-sense timeline of a voluntary action. The timeline should go like this. First you decide, then your brain prepares to move, then your muscles move. That is what it feels like from the inside. Consciousness leads, the brain follows. Here is what actually happens. The readiness potential, a buildup of electrical activity in the supplementary motor area, begins approximately 550 milliseconds before movement onset. It can begin as early as 1200 milliseconds before. Conscious awareness of the decision to move, the moment the subject reports wanting to move, occurs approximately 200 milliseconds before movement, and the movement itself follows. The readiness potential precedes conscious awareness by approximately 350 milliseconds. Your brain begins preparing for a voluntary action several hundred milliseconds before you are aware of deciding to take it. The decision you experience as happening now has already been in progress for over a third of a second by the time you become aware of it. Libet wrote it plainly. The initiation of voluntary action begins before an individual makes a conscious decision to move. This experiment provoked a firestorm that has lasted decades. More than 2,200 follow-up publications, philosophers, neuroscientists, psychologists, and legal scholars all weighed in. Daniel Dennett argued that the methodology for timing subjective reports was too imprecise to draw strong conclusions. Others pointed out the artificial simplicity of the task, that flexing a finger on cue is nothing like the complex deliberations of real life. And these are valid criticisms, but they miss the point that matters for this script. Libet's experiment is not primarily about free will. It is about the timing of now. The common misunderstanding is that Libet proved free will does not exist. He did not. In fact, Libet himself believed in free will until the day he died. He proposed what he called free won't, the idea that even though the brain initiates actions unconsciously, consciousness retains the power to veto those actions in the final 200 milliseconds before movement. He noted that most of the 10 Commandments are framed as prohibitions, thou shalt not, rather than commands, which he found consistent with consciousness operating primarily as a vetoing mechanism. He received the first virtual Nobel Prize in psychology from the University of Klagenfurt in 2003. He died on July 23, 2007, at the age of 91. His experiment has been misrepresented more often than it has been understood. What the experiment actually proves, and what matters here, is that the present moment as you experience it is not what it seems. The moment of decision, the feeling of now I choose, arrives in consciousness after the brain has already set the action in motion. Your experience of now is not a window onto the leading edge of reality. It is a report, delivered late, about something that has already begun. And then in 2008, a team led by Chun Seong-soon at the Bernstein Center for Computational Neuroscience in Berlin pushed the finding to a place that makes Libet's 350 millisecond gap seem quaint. Their paper, published in Nature Neuroscience on April 13, 2008, used functional magnetic resonance imaging instead of EEG. Subjects in the scanner freely chose to press either a left or right button whenever they felt like it, and noted which letter was on screen when they became aware of their decision. Using multivariate pattern analysis, the researchers decoded brain activity in the frontopolar cortex, Brodmann area 10, and the precuneus in the posterior parietal cortex. They found that these regions contained information predicting which button the subject would press up to 7 seconds before the subject reported becoming aware of the decision. When you factor in the sluggishness of the fMRI blood oxygen level dependent response, which takes 2 to 3 seconds to reflect underlying neural activity, the predictive information appeared up to 10 seconds before conscious awareness. The prediction accuracy was approximately 60%, where chance would be 50. 10 seconds. Your brain encoded which button you would press 10 seconds before you felt like you were deciding. And you experienced the decision as happening now, in the present moment, as a free, conscious act of will. Whatever now is to you, it is not the moment of decision. It is not the leading edge of consciousness pushing into the future. It is a delayed, edited, time-stamped reconstruction of something that happened long before you knew about it. But even this is not the worst of it, because everything up to this point could still be explained by saying the brain is slow, that there is a real present out there, and the brain just tracks it with a delay, like a security camera that records in real time but shows you the feed a few seconds late. The picture is delayed, but the picture is accurate. What is being shown actually happened, just not at the moment you see it. If that were the case, the forgery would be relatively benign. A timing error. A lag. Nothing more. The postdiction evidence destroys this interpretation completely. In 1972, Frank Geldard and Carl Sherrick at Princeton published a paper in Science describing something called the cutaneous rabbit illusion. The setup is simple. A device delivers rapid taps to two locations on a subject's forearm, say the wrist and the elbow. 5 quick taps at the wrist, then 5 quick taps at the elbow. What the subject feels is not 5 taps at the wrist followed by 5 taps at the elbow. They feel a series of taps that seem to hop up the arm like a rabbit, traveling through skin that was never actually touched. The taps seem to occur at locations between the wrist and the elbow where no stimulus was delivered. Think about what this means for the present moment. The brain cannot know where the second set of taps will land until they arrive. The elbow's taps have not happened yet when the wrist taps are being delivered, and yet the subjective experience of the wrist taps is altered by the elbow taps that come later. The later event rewrites the conscious experience of the earlier event. This is not a delay, this is retroactive editing. The brain is changing your experience of the past based on information from the future. The color phi phenomenon demonstrates the same thing even more vividly, first described by Paul Kohlers and Michael von Grunau in 1976 in Vision Research. 2 colored dots are shown in sequence at slightly different locations. A red dot, then a green dot. The gap between them is a few hundred milliseconds. What subjects perceive is not 2 separate dots. They see a single dot that moves smoothly from the first position to the second and changes color at the midpoint of its trajectory. The dot appears to turn from red to green approximately halfway between the 2 positions. But the subject could not possibly know the dot would be green until the green dot appeared. The color change is assigned to a moment in time and a position in space that precede the information that determined them. Daniel Dennett used this illusion in his 1991 book Consciousness Explained to argue that there is no single moment of conscious experience, no Cartesian theater where the present plays out in real time for a watching self. Instead, consciousness is a process of continuous editorial revision where later information routinely alters earlier experiences before they are finalized. The flash lag effect shows something similar. When a stationary object is briefly flashed in exact alignment with a continuously moving object, the flash is perceived as lagging behind the moving object. They appear spatially offset, even though they were objectively aligned at the moment of the flash. The brain predicts where the moving object will be and adjusts the percept accordingly. But it cannot do this for the unpredictable flash, creating a discrepancy in the conscious present between what was predicted and what actually happened. David Eagleman, a neuroscientist at Stanford who has spent much of his career studying temporal perception, has synthesized these findings into what he calls the postdictive model of consciousness. The brain, Eagleman argues, does not passively record the present with a slight lag. It actively constructs the present using information from a window of approximately 80 to 100 milliseconds around any given event. Information arriving after the event routinely shapes the conscious experience of the event itself. The now you experience is not a recording. It is an edit, a composite assembled from past and future inputs, stitched together to create the illusion of a seamless present that never existed in real time. Eagleman tested the limits of this illusion with one of the more creative experiments in modern neuroscience. In 2007, he published a paper in PLOS 1, co-authored with Ches Stetson and Matthew Fiesta. The question was whether time genuinely slows down during frightening events, as many people report. The setup was striking. Subjects at the zero-gravity thrill park in Dallas, Texas, were dropped in free fall from approximately 31 meters, about 150 feet, for roughly 3 seconds. They wore a device strapped to their wrists called a perceptual chronometer. It flashed random digits alternating with their negative images at a rate just faster than the subject's visual resolution threshold. If time genuinely slowed down during the fall, subjects should have been able to read the numbers, because the flashing would appear slower from their perspective. They could not. Time did not slow down during the fall. There was no increase in temporal resolution, but subjects did retrospectively estimate their fall duration as 36% longer than when they watched someone else fall the same distance. Eagleman's conclusion was stark. Time slowing is a function of recollection, not perception. A richer encoding of memory may cause a salient event to appear retrospectively as though it lasted longer. Even your sense of how fast time is passing is not a direct perception. It is a retrospective judgment shaped after the fact by how much detail your memory encoded. The present, the flow, the speed of time, all of it is constructed backward. And the construction has a physical substrate. In the late 1990s, the German neuroscientist Ernst Poppel published a hierarchical model of temporal perception in Trends in Cognitive Sciences that laid out the architecture of the brain's time factory. At the lowest level, events within approximately 30 to 40 milliseconds of each other are perceived as simultaneous. You cannot tell them apart. They are fused into a single now. Above this, at approximately 100 to 150 milliseconds, perceptual cycles create the frames of conscious experience. Your brain samples reality in discrete snapshots, linked to alpha and theta oscillations in the EEG at roughly 7 to 13 cycles per second. Each snapshot is assembled, edited, and fused with the next to create the illusion of continuity. And at the highest level, the conscious present, the window within which you feel events are happening now, spans approximately 2 to 3 seconds. William James described this over a century ago in his 1890 book, The Principles of Psychology. In a chapter called The Perception of Time, James wrote that the practically cognized present is no knife edge, but a saddleback with a certain breadth of its own on which we sit perched, and from which we look in 2 directions, into time. The term he used, borrowed from the writer E.R. Clay, was the specious present. Clay had coined it in 1882 and defined it with startling clarity. The present to which the datum refers, Clay wrote, is really a part of the past, a recent past, delusively given as being a time that intervenes between the past and the future. Let it be named the specious present. Specious, meaning superficially plausible, but actually wrong. The present is a lie. It has been recognized as a lie since 1882, and the neuroscience of the last 40 years has merely confirmed the mechanism of the deception. Recent work has made this even more concrete. In 2016, Rufin van Rullen published a landmark review in Trends in Cognitive Sciences showing that brain oscillations create periodic sampling of sensory input. Perception consists of rapid sequential snapshots, not a continuous stream. A 2015 study by Baumgarten, Schnitzler, and Lang in the Proceedings of the National Academy of Sciences used magnetoencephalography to show that 2 tactile stimuli falling within 1 oscillatory cycle are merged into a single percept, while stimuli spanning 2 cycles are perceived as distinct events. The brain is not filming reality, it is taking still photographs and running them together like a flipbook. The motion, the flow, the continuity of now is an animation created by your visual cortex. And every frame of that animation is already in the past by the time you see it. So here is where you are. Physics says the present does not exist in any fundamental equation. Special relativity says simultaneity is observer-dependent. General relativity says there is no preferred way to slice space-time into moments. The Wheeler-DeWitt equation says the universe does not evolve. The thermal time hypothesis says time itself may be generated by statistical ignorance. And neuroscience says your brain fabricates the experience of now roughly half a second after the fact, backdates it to hide the delay, retroactively edits it using information from events that have not happened yet, and assembles the whole thing from discrete snapshots taken at 7 to 13 frames per second and fused into the illusion of a continuous present. You have never experienced the present moment, not once, not for a single millisecond of your entire life. What you have experienced every time is a reconstruction, a temporal composite, a forgery so complete that it convinced you it was the one thing in the universe that could not possibly be faked. And the question that should be forming in your mind right now, if the physics is right and the neuroscience is right, is not how is this possible? It is the darker question underneath. If the universe has no now, and the brain is manufacturing one, then what is the brain manufacturing it from? What is the raw material of this illusion? What is the thing that sits beneath the fabrication, the thing you would see if you could strip the forgery away and look at what is actually there? That question leads to the most unsettling place this story goes, and it begins with a man who gave up a career in physics to spend 30 years translating Russian scientific journals from a farmhouse in the English countryside, because the question of what exists beneath the illusion of time was more important to him than anything the academic world had to offer. His name was Julian Barbour. He was born on February 13th, 1937, in Jerusalem, and the moment that set the course of his life happened on an October afternoon in 1963. He was traveling by train to climb the Watzmann, a mountain in the Bavarian Alps. He had brought something to read for the journey, a copy of Scientific American containing an article by Paul Dirac, one of the founders of quantum mechanics, questioning whether it was correct to unify space and time into space-time. Dirac was suggesting that maybe time needed to be treated differently from space. Maybe they should not have been merged. Barbour never climbed the mountain. He stayed in a hillside hut that night and woke with a splitting headache. He spent the entire next day thinking about nothing except the meaning of time. He did not stop thinking about it for the next 60 years. After earning his doctorate at the University of Cologne in 1968, Barbour faced a choice that would define his life. Felix Pirani at King's College London was blunt with him. If you want a career position, Pirani said, you have to produce 2 solid research papers a year and do your lectures and administration. Can you do it? Barbour thought about the question of time, about the depth of the problem, about the years of uninterrupted thought it would require. He did not think he could do both, so he walked away from academia. He returned to England, bought a farmhouse called College Farm in the village of South Newington, near Banbury in Oxfordshire. Using money from his father, he and his wife Verena raised 4 children there: Boris, Jessica, Naomi, and Dorcas. And from 1969 to 1997, nearly 3 decades, Barbour funded his physics research by translating Russian scientific journals into English for publishers including the American Institute of Physics. He would translate by day and think about time by night. He had no salary, no department, no tenure committee, no graduate students. Just a man in a farmhouse, working on what he believed was the deepest question in physics, sustained by translation work and stubbornness. What Barbour concluded, after those decades of work, is the most extreme position in the time debate. And it is the position that ties together everything in this script, from Einstein's letter to Libet's electrodes to the Wheeler-DeWitt equation, into a single, coherent, deeply unsettling picture. Time, Barbour argues, does not exist, not in any sense, not as a flow, not as a dimension, not as an emergent property of thermodynamics, not as a parameter in a wave equation. It does not exist. What exists is a collection of what Barbour calls nows. Each now is a complete configuration of the universe, a single frozen snapshot of every particle, every field, every relationship. These nows do not come in sequence. There is no ordering. There is no before and after. There is no motion from one to the next. They simply exist, all of them, in a timeless space that Barbour calls Platonia. You, right now as you hear this, are a now. You are a single, static configuration, and you contain something Barbour calls a time capsule. A time capsule is any fixed pattern that creates or encodes the appearance of motion, change, or history. A fossil is a time capsule. It is a static pattern in rock that encodes the appearance of an organism that once lived. A photograph is a time capsule. It is a fixed arrangement of pigments that encodes the appearance of a moment that once happened. Your brain, Barbour says, is a time capsule. It contains neural configurations that encode what feel like memories of a past, predictions of a future, and the sensation of a flowing present. But in Barbour's framework, that past never flowed into this present. These memories are structural features of a frozen configuration. They were not created by time passing. They are patterns in a static snapshot that creates the illusion that time has passed. Yesterday does not come before today. Today simply contains records that create the impression of a yesterday. You are not someone who has lived through the past and is now experiencing the present and is heading toward the future. You are a frozen configuration that contains the appearance of having done all of those things. And the experience of now, the thing that feels more real than anything else, is just what this particular configuration feels like from the inside. If that does not unsettle you, you have not fully absorbed it, because Barbour is not talking about the universe in the abstract. He is talking about you, about the thing you call yourself, about the continuity of your identity across time, the feeling that you are the same person who woke up this morning, the same person who was a child 30 years ago, the same person who will be older tomorrow. In Barbour's framework, there is no continuity, there is no thread of identity linking past and present. There are only nows, each containing a time capsule that encodes the illusion of continuity. You are not a river of consciousness flowing through time. You are a still photograph that believes it is a movie. John Archibald Wheeler, not a man easily impressed, read Barbour's book, The End of Time, and said this: Plato and Aristotle, if they had read it, would still be discussing it, because it deals with that greatest of all mysteries, how come existence? But Barbour's view raises a question that is even more disturbing than the view itself. If time capsules are all that exist, if each now is a frozen configuration that merely contains the appearance of history, then why do the time capsules look like this? Why do they encode a coherent past? Why do they contain memories that fit together into a consistent story? Why is the illusion so perfect? What is selecting for time capsules that contain the appearance of a universe with a history, with laws of physics, with evolution, with you? And this is where the story reaches for something that physics cannot yet grasp, something that sits at the edge of what is known, something that the people who understand the math best are not willing to say out loud, because saying it out loud would require them to confront implications about the nature of consciousness, the nature of identity, and the nature of reality that the entire framework of modern physics was not built to handle. Barbour's answer to why the time capsules encoded coherent history is, at first glance, deceptively simple. He appeals to the same principle that explains why we find ourselves on a planet with oxygen rather than floating in empty space. It is not that oxygen-rich planets are the only configurations that exist. It is that oxygen-rich planets are the only configurations that contain the kind of complex structure capable of asking why it exists. Barbour applies this reasoning to nows. Plutonia contains every possible configuration of the universe. Most of them are featureless. Random arrangements of particles with no structure, no patterns, no records. But a small subset of configurations are what Barbour calls time capsules. Configurations that contain internal records which give the appearance of a coherent history. Configurations complex enough to contain observers who notice those records and interpret them as evidence of time having passed. We find ourselves in time capsules not because time is real, but because only time capsules contain the kind of structure that asks questions. This sounds almost reassuring until you think about what it actually requires. It requires that the appearance of your entire past, every memory you have, every record of every event you think happened, is not evidence that those events occurred in sequence. It is a structural feature of the particular now you inhabit. The fossil record is not proof that dinosaurs lived millions of years ago. It is a pattern in a frozen configuration that is consistent with a history in which dinosaurs lived millions of years ago. Your memory of breakfast this morning is not proof that breakfast happened. It is a neural pattern that encodes the appearance of breakfast having happened. And here is the part that Barbour states with characteristic calm, but that should feel like the ground shifting under your feet. There is no way, even in principle, to distinguish between a now that was caused by a history and a now that simply contains the appearance of one. If you are a time capsule, you cannot reach outside yourself to verify that the past your records describe actually occurred. You are sealed inside the illusion. The illusion is all you are. Difference merely creates an illusion of time, Barbour wrote, with each individual moment existing in its own right, complete and whole. We have no evidence of the past other than our memory of it, and no evidence of the future other than our belief in it. Read that again. We have no evidence of the past other than our memory of it. That is not a philosophical provocation. It is a strict empirical claim. You cannot access the past. You cannot reach back through time and verify that yesterday happened. All you have is the present tense existence of records, memories, fossils, photographs, written documents, all of which exist now, in the current configuration of reality. You interpret them as evidence of a past. Barbour says they are structural features of a present configuration. The difference sounds academic until you realize its implications. If Barbour is right, the past did not happen in any meaningful sense. It is encoded in the structure of the now, like a story written into the arrangement of atoms, but the story was never performed. The script exists. The play does not. And Plutonia, the space of all possible nows, has a structure. It is not an amorphous blob. It has a geometry. Configurations that are similar to each other are close together in Plutonia. Configurations that differ greatly are far apart. Barbour showed that the laws of physics, reinterpreted in this timeless framework, determine which nows are probable, which configurations are the ones where the quantum mechanical amplitude is concentrated, and the configurations with high amplitude, the ones that are in some sense more real, are precisely the time capsules, the configurations that contain internal records of a consistent history. The universe does not evolve through a sequence of nows, but the structure of Plutonia strongly favors nows that look as though the universe has evolved through a sequence. The illusion of time is not random, it is selected for. It is, in a sense, the universe's most probable pattern. What really intrigues me, Barbour wrote, is that the totality of all possible nows of any definite kind has a very special structure. You can think of it as a landscape or country. I call it Plutonia because it is timeless and created by perfect mathematical rules. Barbour published The End of Time in 1990. The response from the physics community was a mixture of admiration and discomfort. Nobody disputed the mathematical framework. The Wheeler-DeWitt equation does describe a timeless universe. The problem of time in quantum gravity is real. Barbour's interpretation of what this means is logically consistent. But most physicists could not bring themselves to accept it. Not because of the math, because of what it implies about the person doing the math. And this is where Barbour's framework intersects with something that was happening independently in quantum mechanics, something that would decades later be experimentally verified in a laboratory in Turin, Italy, something that takes the idea of a timeless universe and shows not just that it is philosophically coherent, but that it is physically possible to construct the appearance of time from a universe that contains none. In 1983, the same year Benjamin Libet published his readiness potential paper, two physicists named Don Page and William Wheeler published a paper in Physical Review D called Evolution Without Evolution, Dynamics Described by Stationary Observables. The title itself is a contradiction that captures the entire problem. How can there be evolution change dynamics in a system that is stationary? Their answer was entanglement. Here is the proposal. Start with the Wheeler-DeWitt equation. The wave function of the universe does not evolve. It satisfies the constraint equation, and the right-hand side is zero. The universe, as a whole, is static. But now divide the universe into two subsystems. Call one of them a clock, and call the other everything else. These two subsystems are correlated. And Page and Wootters showed that if an observer is correlated with the clock subsystem, if the observer is part of the clock or uses the clock to define when things happen, then that observer will see the rest of the universe evolving in time. The equations of quantum mechanics will appear to hold, states will change, things will happen, there will be a before and an after. But this time, this evolution, this apparent flow, is not a property of the universe. It is a property of the entanglement between subsystems. From the perspective of an external observer, one who can see the entire universe at once without being correlated with either subsystem, the total state is perfectly static. Nothing changes. Nothing moves. The wave function just sits there. Both perspectives are correct. The internal observer sees time. The external observer sees timelessness. The disagreement is not about physics. It is about which subsystem you're entangled with. Time is not a feature of reality. It is a feature of your position within it. For 3 decades, this was a theoretical curiosity, an elegant idea with no experimental support. Then in 2014, a team led by Ekaterina Mareva at the Italian National Institute of Meteorological Research in Turin published a paper in Physical Review A titled Time from Quantum Entanglement, an experimental illustration. They used entangled photon pairs. One photon played the role of the clock. The other played the role of the system being observed. When they measured the internal observer's perspective, correlated with the clock photon, the system photon appeared to evolve. Its polarization state changed over time. When they measured the external perspective, looking at the global state of both photons together, the total state was static. No evolution. No time. The experiment was small. 2 photons is not a universe, but it demonstrated the principle. Time can emerge from entanglement in a globally timeless system. The experience of flow, of change, of now, can be generated by quantum correlations between subsystems, with no actual temporal evolution taking place at the fundamental level. There is something viscerally unsettling about this experiment that the physics notation obscures. 2 photons are created in an entangled state. Their polarizations are correlated. One photon is designated the clock. The other is the system. A detector that looks at the clock photon and the system photon together, seeing the whole picture, measures a static state. Nothing happens, nothing changes. The entangled pair just sits there, timeless, like a sculpture. But a detector that looks only at the system photon, using the clock photon as a reference, sees the system photon's polarization rotating over time. Evolution, change, a before and after. A now that moves. Same photons, same entangled state, same physical system. Two ways of looking at it produce two entirely different realities, one with time, one without. And neither is wrong. The time-containing reality is not an error. It is a genuine description of what the system looks like from one perspective. The timeless reality is also genuine. It is what the system looks like from another perspective. Time is not in the system. Time is in the looking. When Mareva and her colleagues published these results, the response was muted. No headlines, no public debate. A few hundred citations in the specialist literature. A quiet acknowledgement within quantum gravity circles that the theoretical framework of Page and Wootters, proposed 3 decades earlier, had experimental support. And then silence. The finding that time might be an artifact of entanglement, confirmed in a laboratory with real photons, was published, verified, and filed away. Just as every other finding in this story has been published, verified, and filed away, the pattern of suppression is itself a pattern worth noticing. Not suppression by conspiracy, these results are not hidden, they are available to anyone who looks. But almost nobody looks, because looking means confronting something about your own experience that is very difficult to confront. A 2021 paper in Nature Communications by Foti, Coppo, Barney, Braggio and Buscemi pushed this further. Their conclusion was stated with a directness unusual for an academic paper. There is not a quantum time possibly opposed to a classical one. There is only one time, and it is a manifestation of entanglement. Time is what entanglement looks like from the inside, and in 2025, a team led by Alexander Favalli at the University of Naples extended the Page-Wootters mechanism to spatial dimensions, constructing a model in which 3+1 dimensional space-time, 3 dimensions of space and 1 of time, emerges entirely from entanglement. They showed that this emergent space-time is consistent with time dilation as described by the Schwarzschild solution to Einstein's field equations. Space-time itself, not just time but space too, may be nothing more than entanglement viewed from a particular perspective. Think about what this means for the present moment. In the Page-Wootters framework, now is the correlational structure between you and whatever you are using as a clock. It is not a property of the universe. It is a property of your entanglement with one part of the universe. A different observer, entangled with a different clock, would experience a different now, and an observer outside the system, if such a thing were possible, would see no now at all, just a static wave function, eternal and unchanging. Your now is not a moment in the history of the universe. It is a shadow cast by your entanglement with one of its pieces. And here is where the convergence becomes something more than academic, because the thermal time hypothesis says time is generated by statistical ignorance. The Page-Wootters mechanism says time is generated by entanglement. Barbour says time is an illusion encoded in frozen configurations. The Wheeler-DeWitt equation says the universe does not evolve. Special relativity says simultaneity is observer-dependent. General relativity says there is no preferred foliation into moments. Neuroscience says the brain fabricates now half a second late and backdates it. Libet says the readiness potential precedes conscious awareness by 350 milliseconds. Soon says the brain encodes decisions 10 seconds before you feel them. Eagleman says even the speed of time is a retrospective judgment. These are not different theories about time. They are the same conclusion, arrived at independently by different fields using different methods over the course of a century. And the conclusion is that the present moment does not exist in any description of reality, physical, neurological, or philosophical, except as something generated by the limitations, the ignorance, or the entanglement structure of the observer. This should be front-page news. It should be the subject of public debate and cultural reckoning. The present moment, the one thing every human being considers the bedrock of their experience, has been shown by the hardest sciences we have to be a construction, a fabrication, an artifact. And the response from the scientific community, the media, and the culture at large has been almost complete silence. The papers were published, the experiments were run, the results were verified, and then nothing. No headlines, no public discussion, no reckoning with what it means, just a quiet filing away of the most disturbing finding about human experience that science has ever produced. And the evidence keeps accumulating. In 2017, a team led by Giulia Rubino experimentally verified quantum processes where neither event A happening before event B, nor event B happening before event A, is definite. The temporal ordering itself was in quantum superposition. They violated a causal witness inequality by almost 7 standard deviations. The order in which things happen is not fixed. It is not a fact about the universe. It can be in superposition, just like the position of an electron. When something happens is as uncertain as where something is. In 2020, Esteban Castro Ruiz, Flaminia Giacomini, and Kaslav Bruckner at the University of Vienna published a paper in Nature Communications showing that when quantum clocks interact gravitationally, the time localizability of events becomes relative to the reference frame. In other words, at the intersection of quantum mechanics and general relativity, the point where our two deepest theories meet now itself becomes fuzzy, not merely observer-dependent, as in special relativity, genuinely indeterminate. The concept of a sharp temporal location for an event breaks down entirely when gravity and quantum mechanics are both in play. And in 2025, a paper by Daniela Angulo and colleagues, peer-reviewed and published in APL Quantum, reported experimental evidence consistent with photons spending a negative amount of time as atomic excitations during resonance scattering. Negative time, not ambiguous time. Negative. The photon appears to leave the atom before it enters. The authors were careful to note that this does not violate causality, that the effect occurs within the uncertainty bounds of quantum mechanics, and that it does not mean information traveled backward, but it means that at the quantum level, even the sign of the temporal duration of an event is not what your classical intuition says it should be. Every year, the experimental evidence for the non-existence of the present gets more precise, more rigorous, more impossible to dismiss. And every year, it receives less public attention. Rovelli's The Order of Time was a bestseller, yes, but it was marketed as an elegant meditation on the nature of time, not as what it actually is, which is a detailed, evidence-based argument that the present moment you are experiencing right now is a fabrication with no counterpart in fundamental physics. The book was reviewed in the culture pages, not the news pages. It was shelved in the popular science section next to books about black holes and dinosaurs and the search for extraterrestrial life, as though the non-existence of now were a curiosity of the same order as the existence of exoplanets, rather than a finding that strikes at the core of what it means to be a conscious being. But there is a dissenter, and his dissent matters, not because it rescues the present moment, but because it reveals exactly how much is at stake if the present cannot be rescued. Lee Smolin is a theoretical physicist at the Perimeter Institute for Theoretical Physics in Waterloo, Ontario. He is one of the founders of loop quantum gravity, alongside Rovelli and Ashteker. He is also, in some sense, Rovelli's opposite. They built the same theory together, they share the same mathematical framework, and they disagree about the most basic question in physics. Rovelli says, time does not exist. Smolin says time is the most real thing there is. They have debated this publicly, in papers and at conferences, with the kind of respectful intensity that only two people who genuinely understand the stakes can manage. Because the stakes are not academic, the stakes are everything. In his early career, Smolin was sympathetic to the timeless view. His first book, The Life of the Cosmos, published in 1997, praised Barbour's work and took seriously the idea that time might be illusory, but something changed, and Smolin has been unusually candid about what it was. In his 2013 book Time Reborn, Smolin wrote that his motivation was best described in the language not of science but of fatherhood, through the conversations he had with his young son, especially when he put him to bed at the end of the day. Fatherhood made the timeless universe intolerable. If time is not real, Smolin realized, then the moment he was tucking his son into bed, the moment of warmth and connection and presence, was not happening. It was a frozen pattern in a configuration space, a time capsule, an illusion of now generated by entanglement or ignorance. And Smolin could not accept that, not as a father, and not, he decided, as a physicist. There is something raw in Smolin's admission that you do not find in most physics books. He is saying that his philosophical position on the nature of time was changed not by a new equation or a new experiment, but by the experience of holding his child. And he is saying this without embarrassment, because he believes the experience itself is evidence. The experience of the present moment, the experience that every physicist in the timeless camp dismisses as an illusion, is, for Smolin, data. It is information about reality that the equations have not yet learnt to capture. Smolin's argument in Time Reborn is sweeping. Whatever is real in our universe is real in a moment of time, which is one of a succession of moments, he wrote. The past was real, but is no longer real. The future does not yet exist, and is therefore open. And then the line that separates him from nearly every other theoretical physicist working on these problems. Nothing transcends time, not even the laws of nature. Laws are not timeless. Like everything else, they are features of the present, and they can evolve over time. This is a radical claim. Most physicists treat the laws of nature as eternal truths that exist outside of time, unchanging since the Big Bang, or perhaps even before it. The laws are the stage on which the drama of the universe plays out, and the stage does not change. Smolin says the stage is part of the drama. The laws themselves are born with the universe and can change. He proposes cosmological natural selection, the idea that universes reproduce through black holes, and that the laws of physics in each child universe are slightly mutated from the parent. Our universe has the laws it has because those laws are good at making black holes, which make more universes, which make more black holes. He originally published this idea in 1992, more than 2 decades before Time Reborn, and it remains one of the few genuinely testable proposals in quantum cosmology. Time, in this framework, is not an illusion. It is the most fundamental thing there is. Everything else, including the laws, exists within time and is subject to change. Smolin connected this to human stakes with an urgency that is rare in physics writing. How we think about the future and the past determines everything about how we think about our situation as human beings, he wrote. Our freedom, agency, will, discovery, invention, surprise, genuine. If time is an illusion, so are they. This is not a man arguing about equations. This is a man arguing about whether anything matters. If the present is a fabrication, then so is agency, so is the experience of tucking your child into bed and feeling that this moment, right now, is real. is happening matters. And the debate between Smolin and Rovelli is not a debate that physics can resolve, because it is not, at bottom, about physics. It is about what counts as evidence. Rovelli looks at the Wheeler-DeWitt equation, the thermal time hypothesis, the Lorentz transformation, and he sees a universe without time. Smolin looks at the same equations and then looks at his son's face and sees a universe where the equations are incomplete. They are both brilliant, they are both rigorous, they are both honest, and they disagree about the most fundamental question there is, which tells you something about the state of the problem. But here is the thing about Smolin's defense that makes it less comforting than it first appears. Even if he is right, that time is fundamental, even if the laws of nature evolve and the future is genuinely open, his argument does not rescue the present moment as you experience it. Smolin defends the reality of temporal succession, the idea that one state of the universe gives way to the next. But the neuroscience still stands. Your experience of now is still fabricated half a second late. Your decisions are still encoded before you become aware of them. Your perception is still assembled from discrete snapshots and retroactively edited. Smolin may have saved time, but he has not saved the present. The now you feel is still a construction, even if the temporal framework it is constructed within is real. And Smolin knows this. He has never claimed to have solved the problem of conscious experience. His argument is about cosmology, not neuroscience. The problem of the present is deeper than any single discipline can reach. It sits at the intersection of physics, neuroscience, and philosophy, and it has resisted every attempt to resolve it from within, any one of those fields. And there is something telling about the way each field handles its piece of the problem. The physicists say the present does not exist in their equations, but that the experience of the present is outside their jurisdiction, a question for neuroscience or philosophy. The neuroscientists say they can show how the brain constructs the experience of the present, but that what the brain is constructing it from, the relationship between neural processes and subjective experience, is the hard problem of consciousness, and it is outside their jurisdiction. And the philosophers say they can analyze the logical structure of temporal experience and the metaphysics of time, but that the empirical questions about what is happening in the brain and what the equations of physics actually say are outside their jurisdiction. Each field passes the deepest part of the question to one of the other two. And when you follow the chain all the way around, you discover that nobody has jurisdiction over the central mystery. The question of what the present actually is, of what is generating the experience you are having right now, falls through the cracks between physics, neuroscience, and philosophy. It belongs to all of them and none of them. It is the question that each discipline assumes the others will answer, and none of them do. This jurisdictional void is not an accident, it is structural. The problem of the present requires a kind of understanding that does not currently exist, one that would need to be simultaneously physical, neurological, and experiential. It would need to explain how timeless equations produce systems that experience time, how frozen patterns generate the feeling of flow, how a brain that is, at the level of fundamental physics, a static arrangement of particles in a four-dimensional block, produces the vivid, irrefutable, overwhelming experience of being here, now, in this moment, hearing these words, aware that they are being heard. Nobody has this understanding, and the history of attempts to reach it is the history of the smartest people in the world walking up to the edge of the deepest question and finding that their tools stop working. At the 2016 Time in Cosmology conference at the Perimeter Institute, the physicist Avshalom Elitzur stood up and said something that captured the frustration of everyone in the room who felt the weight of this problem. He said he was sick and tired of the block universe. He said he did not think next Thursday had the same ontological footing as this Thursday. And then he said, with a directness that startled the other physicists present, "The future does not exist. It does not. Ontologically, it is not there. The room went quiet, not because the claim was new, but because a respected physicist had said it with the emotional force of someone who meant it personally, not just professionally. Elitzer was not presenting a paper. He was making a confession. He was saying that the standard interpretation of the physics he had spent his career working on was something he could not live with, and the silence in the room suggested he was not the only one. You can watch the video of this moment. It is available online from the conference recordings. And what strikes you when you watch it is not the argument, it is the tone. Elitzer is not calmly presenting an alternative interpretation. He is pushing back against something that feels like a wall closing in. He knows the math. He has worked with the equations. He understands the Rietdijk-Putnam argument, the block universe, the Wheeler-DeWitt equation, and he is saying, with the authority of someone who has seen all the evidence and understands its implications, that he refuses to accept the conclusion. The future does not exist. It is a statement of defiance. And defiance, in physics, is usually a sign that the conclusion being defied has teeth. Compare this with how Einstein handled the same problem privately, decades earlier. In a conversation recorded by the philosopher Rudolf Carnap in his intellectual autobiography, published in the Schilp volume The Philosophy of Rudolf Carnap in 1963, Einstein told Carnap that the problem of the now worried him seriously. This was not a throwaway remark at a dinner party. This was Einstein, in a private conversation with a leading philosopher of science, admitting that something about his own theory genuinely disturbed him. Einstein said that the experience of the present moment means something special for humans, something essentially different from the past and the future, but that this important difference does not and cannot occur within physics. And then Einstein said something that Carnap recorded carefully, because it was so uncharacteristic of the man who had revolutionized physics with the confidence of a 26-year-old patent clerk. Einstein said that the fact that science could not grasp this experience seemed to him a matter of painful but inevitable resignation. Painful, inevitable, resignation. 3 words that tell you more about the state of the problem than any equation. The man who built special relativity, the man who eliminated the universal present, the man who wrote to Besso's family that the distinction between past, present, and future is a stubbornly persistent illusion, that same man found the elimination of the present to be painful. He did not celebrate it. He did not find it liberating. He found it agonizing, and he saw no way around it. Resignation, not hope that a deeper theory would restore the now, not confidence that future physics would explain the experience. Resignation. He accepted it the way you accept something that hurts and cannot be changed. The British astronomer Arthur Eddington, who had led the 1919 solar eclipse expedition to Principe Island off the coast of West Africa, that confirmed general relativity's prediction of light bending around the sun, who had made Einstein a global celebrity overnight, pushed back in his own way. Eddington argued that our intuitive sense of time's passage is so powerful, so fundamental to consciousness, that it must correspond to something real. If science cannot get a purchase on it, Eddington wrote, one might say, well, so much the worse for science. That is a remarkable sentence from one of the leading scientists of the 20th century. It is an admission that the subjective experience of now is so undeniable, so central to what it means to be conscious, that a physicist was willing to declare the entire scientific enterprise insufficient rather than deny the experience. But Eddington's defiance, like Elitzer's, did not solve the problem. It just restated it with more emotion. The experience of the present is real as an experience. The physics says it does not correspond to anything in the external world. And the neuroscience says it is a fabrication constructed after the fact, backdated, retroactively edited, and assembled from discrete snapshots. You are left with an experience that cannot be denied, that has no counterpart in reality, and that is being manufactured by a process you have no conscious access to and no ability to override. A fabrication you cannot opt out of, a lie you cannot stop believing, not because you are gullible, but because the lie is you. And this is where the story must go to a debate that happened over a century ago in Paris, because it turns out that everything this script has described, the collision between physical time and experience time, between the equations and the feeling, was anticipated by two men arguing in a lecture hall in 1922. One of them was Einstein. The other was the most famous philosopher in Europe. And the argument between them was never resolved, and its irresolution is exactly the unresolved center of the problem you are confronting right now. On April 6, 1922, Albert Einstein, age 43, delivered a lecture on relativity at the Société Française de Philosophie in Paris. In the audience was Henry Bergson, age 62. Bergson was not a minor figure. He was arguably the most celebrated intellectual in France. His lectures at the Collège de France drew such large crowds that people stood in the aisles and spilled into the corridors. His philosophical work on time, consciousness, and the nature of experience had made him an international celebrity. He would win the Nobel Prize for Literature in 1927. Einstein, of course, had won the Nobel Prize for Physics in 1921, though notably not for relativity. The Nobel Committee avoided relativity because it was still considered controversial, and some historians, including Jimena Canales, have argued that Bergson's public criticism of the philosophical implications of relativity contributed to the committee's caution. The meeting was not a formal debate, it was a lecture followed by discussion. But what happened in the discussion became one of the most consequential intellectual confrontations of the 20th century, because it was not an argument about equations. It was an argument about what reality is allowed to include. Bergson had prepared extensively. He had published Duration and Simultaneity earlier that year, an entire book devoted to the philosophical implications of special relativity. He was not attacking the science. He accepted the Lorentz transformation, the relativity of simultaneity, the constancy of the speed of light. What he challenged was the claim that physics had said the final word about time. Bergson argued that Einstein had conflated two fundamentally different things. There is the time that physics measures, the time of clocks and equations, and coordinate transformations, what Bergson called le temps. And there is the time of lived experience, the continuous qualitative heterogeneous flow of conscious duration, what he called la durée. Real time, Bergson argued, is not a series of discrete instants like points on a spatial line. It is a flowing continuity in which past, present, and future interpenetrate, in which each moment carries the weight of all the moments that came before it, in which the experience of now is thick with memory and anticipation. You cannot capture it by spatializing it, by laying it out as a fourth coordinate on a Minkowski diagram. The attempt to reduce experience time to the time of physics is like trying to capture the experience of a melody by measuring the frequency and amplitude of each individual note. The measurements are correct. They are also profoundly incomplete. They miss the music. Bergson's key concept was durée, duration. He had developed it across 30 years of published work, beginning with his doctoral thesis Time and Free Will in 1889. Duration is not clock time. It is the lived experience of temporal passage. When you listen to a piece of music, each note you hear carries within it the memory of the notes that came before and the anticipation of the notes to come. The present moment is not a knife edge. It is saturated with past and future. It flows, it has quality, texture, direction, and it cannot be captured by any mathematical representation that treats instants as dimensionless points arranged along a line, because the whole point of duration is that the moments are not separable. They bleed into each other, they interpenetrate. An instant of duration, stripped of its connections to what came before and what comes after, is not time at all. It is a spatial abstraction imposed on something that is inherently non-spatial. Einstein's response was devastating in its brevity. "There is no time of the philosophers," he said. "Il n'y a donc pas un temps different from the time of the physicist." The implication was clear. Whatever Bergson was talking about, whatever duration meant, it was subjective, psychological, not physics, not real. The time of physics is the only time there is, and if your experience of time does not match the physics, that is a problem with your experience, not with the physics. Bergson was humiliated. The intellectual world largely sided with Einstein. Physics had spoken. Duration was demoted to psychology. The experience of the present was filed under subjective illusion and left there for decades. Bergson lived another 19 years, dying in Paris in 1941 at age 81 during the German occupation. He had been offered exemption from the Vichy regime's anti-Jewish laws because of his prominence, but he refused it in solidarity with other French Jews. He stood in line for hours to register as Jewish, contracted pneumonia, and died shortly after. Even at the end, Bergson's life was marked by a refusal to accept comfortable fictions. The historian Jimena Canales documented the full scope of this episode in her 2015 book, The Physicist and the Philosopher. She argued that the debate drove a rift between science and the humanities that persists today. A rift in which physics claims exclusive authority over the nature of time, and philosophy is left to discuss only the subjective experience of it, as though the subjective experience were not itself a fact about the universe that requires explanation. Canales concluded that Einstein was scientifically correct but philosophically wrong to dismiss Bergson's insights as merely psychological, because the question Bergson was asking, the question of what it means to experience the present moment, is not answered by saying the present does not exist in the equations. It is sharpened by it. And here is what neither Einstein nor Bergson could have seen in 1922. The neuroscience that would come 60 years later would prove both of them right and both of them wrong, in a way that makes the problem incomparably worse. Einstein was right that physics contains no universal now. The equations of special and general relativity, the Wheeler-DeWitt equation, the thermal time hypothesis, all confirm this. There is no present in the physics. Bergson was right that the experience of duration is irreducible. You cannot explain what it feels like to be in the present moment by pointing to coordinates on a space-time diagram. The experience of now is qualitatively different from any spatial experience. It has direction, it has urgency. It has what Bergson, writing in Matter and Memory in 1896, called the past devouring the future. A continuous interpenetration of memory and anticipation that cannot be decomposed into static instants without destroying the very thing you are trying to describe. Every attempt to reduce duration to physics has failed, not because the attempts were mathematically wrong, but because mathematics operates in the very framework, the spatial, the static, the representational that duration transcends. Bergson saw this in 1889. Nobody has refuted it since. But neither of them anticipated the terrifying synthesis. And this is where the convergence of everything in this script becomes something more than a list of findings from different disciplines. Because the neuroscience does something that neither physics nor philosophy can do alone. It shows the mechanism. It shows how the illusion is produced. And what it reveals is not that the experience of now is a simple error, a glitch in perception that a better brain might avoid. It reveals that the experience of now is the most sophisticated fabrication that any physical system has ever produced. The brain does not merely fail to detect the real present. There is no real present to detect. The brain generates a false present from scratch, using a suite of mechanisms that include half-second delays hidden by backward referral, retroactive editing of past experiences using future information, discrete perceptual snapshots fused into an illusion of continuity at rates of 7 to 13 frames per second, and a 3-second integration window that generates what William James called the specious present, a temporal platform wide enough to stand on but narrow enough to feel like a knife edge. Every one of these mechanisms has been independently verified. Every one of them operates below the threshold of conscious awareness, and every one of them is a physical process happening in a brain that is itself a physical system embedded in the very universe that has no now for any of these mechanisms to track. The feeling of the present is real as an experience. It is generated by neural processes that are themselves timeless events in a block universe. The illusion is manufacturing itself from within the very framework that says it should not exist. This is the problem that David Chalmers calls the hard problem of consciousness, applied specifically to temporal experience. You can explain the neural correlates, you can map the readiness potential, you can trace the backward referral mechanism and the postdictive editing and the oscillatory snapshot architecture. You can describe, in exquisite biophysical detail, every step of the process by which the brain constructs the experience of now. And when you are done, you will not have explained why any of these processes feel like anything. You will not have explained why the 3-second integration window feels like being present rather than feeling like nothing. You will not have explained why the fabrication has an experiencer. The mechanism is visible. The experience is undeniable, and the connection between them is the deepest open question in all of science. And nobody can explain how this bridge is crossed. This is not a gap that will be filled by more data or better experiments. It is a conceptual chasm that sits at the exact point where physics, neuroscience, and the philosophy of mind converge, and where all three disciplines simultaneously declare the problem outside their jurisdiction. The experience of now is a physical process in a universe without now. The fabrication is real, the thing being fabricated is not. And the fabrication is being carried out by a system, the brain, that is itself a time capsule in Barbour's sense, a frozen pattern in a static configuration. That somehow generates the subjective experience of being a dynamic process unfolding in a present moment that the physics says does not exist. Rovelli glimpsed the edges of this problem. In The Order of Time, he wrote that we are time. We are this space, this clearing opened by the traces of memory inside the connections between our neurons. We are memory. We are nostalgia. We are longing for a future that will not come. That is as far as the physics can take you. We are the illusion. The illusion is us. We are time capsules that feel like rivers. And there is something deeply honest in the fact that Rovelli, the man who has done more than anyone to argue that time does not fundamentally exist, chose to describe the human condition in terms of longing and nostalgia. He is not celebrating the timeless universe. He is mourning what it means for us. He is saying that the experience of being a conscious being, the feeling of this moment right now, of being alive, of being here, is the most beautiful thing in the universe, and also the most impossible thing in the universe, because the universe that contains it does not have the machinery to produce it. And yet here it is, produced, experienced, felt, by a system that, according to every equation that same system has ever derived, should not feel anything at all. In an interview years after The Order of Time was published, Rovelli said that the thing about time that disturbs him most is not its absence from the equations. It is the mismatch between what the equations say and what he feels when he holds someone he loves. The equations say that moment is a point in a block. What he feels is that it is everything. Both cannot be true, and he does not know which one is wrong. Barbour saw the same thing from the opposite direction. By a time capsule, he wrote, I mean any fixed pattern that creates or encodes the appearance of motion, change, or history. The mature brain is a time capsule. History resides in its structure. You are a frozen pattern that contains the appearance of a flowing present. The appearance is what you call consciousness. The frozen pattern is what the physics calls reality, and the relationship between the two is the open wound at the center of modern science. Barbour is quieter than Rovelli about the emotional implications. He has spent 60 years on this problem, from the train to the Wattsman to the farmhouse at South Newington, and he does not dramatize. But in an interview for a documentary about time, he once said something that stayed with anyone who heard it. He said that if he is right, if the timeless picture is correct, then every now is eternal. Every configuration of the universe, every moment you have ever experienced, simply is. It does not vanish. When the clock ticks forward, there is no forward. Your happiest moment and your worst moment and this moment right now all exist permanently in Platonia. Nothing is lost because nothing was ever in time to be lost. He meant it as a consolation. Many people who heard it found it the opposite. Because if every now simply is, then you are not a person who lived through those moments and carries them forward as memories. You are a pattern that contains the appearance of having carried them forward. The continuity is not real. The carrying is not records of a journey through time. They are structural features of a frozen snapshot. And the fact that this frozen snapshot also contains the experience of warmth, of love, of being alive in a present moment is a thing that no equation can explain and no physicist can dismiss. It is the raw, unanswerable fact at the bottom of the problem. What you call now is a pattern your brain assembles roughly half a second after the fact. It is backdated to feel immediate. It is constructed from discrete perceptual snapshots taken at 7 to 13 frames per second and fused into a seamless illusion of continuity. It is retroactively edited using information from events that have not happened yet when the editing begins. It operates inside a universe whose most fundamental equation contains no time variable. In a space-time where the distinction between past, present, and future has no objective meaning, in a cosmos where your entire future may already exist, frozen into a four-dimensional block alongside your entire past. And the thermal time hypothesis says even the appearance of flow is generated by your ignorance, by the fact that you do not have access to the full microstate of reality. If you did, time would stop. If you could see the universe as it actually is, there would be nothing happening, nothing flowing, nothing now. You have never once in your life experienced the present moment. What you have experienced every single time is a forgery, assembled after the fact, time-stamped with a false date, edited using future information, stitched from snapshots, projected onto a universe that does not contain it. And the forgery is so total, so seamless, so absolute, that you have spent your entire life inside it without once suspecting it was not real. Einstein knew. He called it a stubbornly persistent illusion and spent his last years walking with a man who had proven that time permits travel to the past. Bergson knew, from the other side, that the experience of duration was irreducible and that physics would never capture it. Libet knew that consciousness lags behind reality and backdates its reports. Barbour knew that what we call history may be nothing more than patterns in a frozen configuration. Rovelli knew that time is what ignorance feels like from the inside. Wheeler knew that the equation he helped create at an airport in North Carolina had no time in it, and he spent the rest of his life trying to understand what that meant. Smolin knew, and it frightened him enough that he wrote an entire book trying to argue his way back to a universe where time is real, motivated not by equations, but by the experience of putting his son to bed. They all knew. Every one of them arrived at the same problem by a different path, and not one of them solved it. Not one of them could explain what the present moment is, what is generating it, what you are in a universe that has no now for you to exist in. The math is done. The experiments are run. The data is in, and the question at the center of all of it, the question this script has been circling for 2 hours, remains open. If the present does not exist, and the brain is building an illusion of it from within a frozen universe, then what is doing the building? What is the thing that experiences the forgery? What is the you that feels like it is here, right now, in this moment? Even though this moment is a construction, and the here is a point in a block universe. And the you is a time capsule that contains the appearance of a life, but may never have lived one. The physicist John Wheeler, near the end of his life, wrote that time puts up the greatest resistance to being dethroned from ideal continuum to the world of the discrete, of information, of bits. He was talking about the physics, but he might as well have been talking about the experience. Time resists being dethroned because the experience of it is total. It is the medium in which you exist. It is the frame of every thought, every memory, every plan, every feeling. To say it does not exist is not like saying the earth is not flat. It is like saying the screen you are watching is not real, that the room you are sitting in is not happening, that the voice you are hearing is not speaking in the present tense. The present moment is the last thing you would give up, the last illusion you would surrender, because it is the illusion that contains all the other illusions. Without it, you are not a person with a history living in a world. You are a pattern in a configuration space that contains the appearance of a person, the appearance of a history, the appearance of a world. And the appearance is all there is. Bergson had a line that neither Einstein nor any physicist since has been able to refute. He wrote it in Matter and Memory, published in 1896, 9 years before Special Relativity, and it strikes harder now than it did then. The pure present, Bergson wrote, is an ungraspable advance of the past, devouring the future. In truth, all sensation is already memory. All sensation is already memory. Every experience you have ever had of the present moment was by the time you had it, a memory. You have never caught the present in the act. You have only ever remembered it, approximately half a second later, through a filter of postdictive editing and backward referral, assembled from snapshots and projected onto a universe that does not contain the thing you think you are projecting. The calculations have been done. The Lorentz transformation is confirmed. The readiness potential is measured. The Wheeler-DeWitt equation has 0 on the right-hand side. The Page-Wootters mechanism has been demonstrated with entangled photons in a laboratory in Turin. The thermal time hypothesis has been published and peer-reviewed. Libet's half-second delay has been replicated and extended. The postdictive editing of conscious experience has been verified across multiple modalities. The specious present has been mapped at every scale from 40 milliseconds to 3 seconds. The evidence is in. The convergence is complete. Physics, neuroscience, and philosophy all arrive at the same place. The present does not exist. And whatever is generating the illusion that it does, whatever process is responsible for the most convincing, most seamless, most total fabrication that any physical system has ever produced, that process is something that the people who understand it best, the physicists and neuroscientists and philosophers who have spent their careers staring at the data, are not able to explain. And the ones who feel the weight of that failure most heavily are the ones who understand that the thing being fabricated is not just the present moment. It is them. It is the experiencer. It is the self that seems to live inside the now. If the now is a forgery, then so is the self that inhabits it. And if the self is a forgery, then the question of what is doing the forging is not a question about physics or neuroscience or philosophy. It is the question, the one that sits beneath all the others, the one that has been open since the first human being looked at the night sky and wondered what they were. Einstein tried to answer it with equations and ended up with a stubbornly persistent illusion. Bergson tried to answer it with philosophy and ended up dismissed as a psychologist. Libet tried to answer it with electrodes and ended up with a gap between the brain and the self that he could measure, but not close. Barbour tried to answer it by abolishing time altogether and ended up with time capsules that explain the structure of the illusion but not the experience of it. Rovelli tried to answer it by making time thermodynamic and ended up with a universe where time is what ignorance feels like, but could not explain what it feels like to feel ignorance. Wheeler tried to answer it by turning everything into information, his famous it from bit, and ended up admitting that time puts up the greatest resistance to being dethroned. Page and Wootters tried to answer it by deriving time from entanglement and ended up proving that time is perspective dependent, but could not explain why perspective feels like something. Smolin tried to answer it by insisting time is real and ended up defending a position that even he admits cannot account for the present moment as you experience it. They all reached for the answer. They all came back empty-handed. And the thing they were reaching for, the present, the now, the experience you are having at this very moment, goes on generating itself from within a universe that has no place for it, using mechanisms that no one fully understands, producing an illusion so complete that the only evidence it is an illusion comes from the illusion itself. Think about that for a moment. The proof that the present is a fabrication was discovered by beings who can only discover things in the present. The equations that eliminate now were written by minds that operate entirely within now. The experiments that expose the backward referral and the postdictive editing and the oscillatory snapshot architecture were conducted by scientists who experienced every moment of those experiments as happening in a present that, according to their own results, does not exist. The fabrication is investigating its own mechanisms, and the conclusion it keeps reaching is that it is an illusion, which is a conclusion it can only reach by using the very illusory now it is trying to debunk. There is a circularity here that nobody has broken. The present moment is both the tool of investigation and the object of investigation. You cannot step outside of now to observe now from a perspective that is not itself embedded in now. You are sealed inside the forgery. You are the forgery investigating itself. And every finding, no matter how rigorous, no matter how mathematically precise, no matter how experimentally verified, is delivered to you in the fabricated present that the finding says does not exist. This is not like other scientific findings about illusions. When you learn that a visual illusion is an illusion, you can step back and see the trick. The Muller-Lyer lines still look different, but you know they are the same length, and you can verify it with a ruler. When you learn that the sun does not revolve around the earth, the illusion persists. The sun still appears to rise and set, but you know the truth, and you can access instruments that confirm it. The temporal illusion is different. When you learn that the present is a fabrication, you cannot step back. There is no ruler, there is no telescope, there is no instrument that will show you reality without the present. Because every instrument, every measurement, every observation, every thought you could possibly have about the problem is itself delivered to you through the fabricated present. The illusion is not something you are looking at, it is the thing you are looking with. It is the lens. And you cannot take off the lens, because the lens is you. Gödel may have understood this better than anyone except Einstein. In his essay for Einstein's 70th birthday, he wrote that the mere compatibility of the existence of time with the laws of nature does not guarantee its actual existence. He was making a logical point about the relationship between equations and reality. but beneath the logic was something darker. Gödel was pointing out that even if you could prove time does not exist, the proof would arrive in time, be understood in time, be remembered in time. The illusion would absorb the proof of its own falsity and continue operating exactly as before. The fabrication cannot be disrupted from within, because within is all there is. Einstein understood this circularity better than anyone. It is why he used the word resignation. He did not say the problem would be solved. He said it could not be solved. Not because the math is too hard, but because the tool you would need to solve it, a perspective outside of experienced time, is the one tool that consciousness cannot provide. You are a process that experiences now. Explaining now would require you to stop being that process. And stopping means ceasing to be the kind of thing that can explain anything at all. Bergson understood this too, from the other side. He wrote in Matter and Memory, 9 years before Einstein published Special Relativity, a line that neither Einstein nor any physicist since has been able to refute. The pure present, Bergson wrote, is an ungraspable advance of the past devouring the future. In truth, all sensation is already memory. All sensation is already memory. Every experience you have ever had of the present moment was by the time you had it, a memory, constructed roughly half a second after the event, backdated to feel immediate, edited retroactively using future information, assembled from discrete snapshots, smoothed into the illusion of continuity, projected onto a universe that does not contain the thing you think you are projecting. You have never caught the present in the act. You have only ever remembered it. And the memory was a forgery. The calculations have been done. The Lorentz transformation is confirmed to extraordinary precision. The readiness potential is measured and replicated across thousands of studies. The Wheeler-DeWitt equation has 0 on the right-hand side. The Page-Wootters mechanism has been demonstrated with entangled photons in a laboratory in Turin. The thermal time hypothesis has been published, peer-reviewed, and extended by multiple independent groups. Libet's half-second delay has been replicated and pushed to 10 seconds by Soon and colleagues. The postdictive editing of conscious experience has been verified across visual, auditory, and tactile modalities. The Specious present has been mapped at every scale from 40 milliseconds to 3 seconds. Quantum indefinite causal order has been confirmed at 7 sigma. The evidence is in. The convergence is complete. Physics, neuroscience, and philosophy all arrive at the same place. And the place they arrive at is a question, not an answer. The present does not exist, and whatever is generating the illusion that it does, whatever process is responsible for the most convincing, most seamless, most total fabrication that any physical system has ever produced, that process is something that the people who understand it best, the physicists and neuroscientists and philosophers who have spent their careers staring at the data, are not able to explain. And the ones who feel the weight of that failure most heavily are the ones who understand that the thing being fabricated is not just the present moment, it is them, it is the experiencer, it is the self that seems to live inside the now. If the now is a forgery, then so is the self that inhabits it. And if the self is a forgery, then the question of what is doing the forging is not a question about physics or neuroscience or philosophy. It is the question, the one that sits beneath all the others, the one that has been open since the first human being looked at the night sky and wondered what they were. You are inside it right now. You have always been inside it, and there is no outside.